Alright guys, today what we're going to learn about is counting atoms. Now, what makes this really difficult is atoms are really small. It's not like we could just count them the same way that we'd count M&Ms or or Skittles or something kind of like that. So there's going to be some new concepts that we're going to learn, and we're going to go back to some of the old ones that we're doing, and we'll kind of explain as we go. Okay, so the first thing that we need to know is that there is this thing that we consider Avogadro's number. Now, Avogadro was, a scientist way back in the day, and this whole idea is that it's the exact number of particles in 1 mole of what we call a pure substance. All that it is it's a conversion factor. Similar to, you don't go buy 12 ears of corn, you don't go buy 24 ears of corn, you buy a dozen ears of corn, or you buy 2 dozen ears of corn, right? You don't go to the grocery store and say, can I have 12 eggs? It just doesn't happen. Instead you say, hey, I'd like a dozen eggs. So, well, in chemistry, we don't want 10 million atoms, we want 0.5 moles, or we want 1 mole of atoms. Okay, so we kind of got to get this idea that a mole is not the little furry thing that digs in the ground, can't see, but it's going to be a unit for, basically it just means a number. So the number that a mole represents is this thing right here. Okay, 1 mole is 6.02 times 10 to the 23rd. Okay, again, this is exactly like 1 dozen is 12 pieces. Right? So this is the exact same thing. Okay? Right? Look how similar they are. 1 mole of something equals a number. 1 dozen of something is the number 12. So we're just using this now as a conversion factor because when we're in chemistry, we need to count with units that make sense for chemistry. So getting rid of this. There we go. All right, so this is just the number. It's just a new number that we really need to make sure that we understand. So 1 mole, anytime that we are ever talking about that in the future, it's this gigantic number, 6.02 times 10 to the 23rd. Now, so that we understand what that actually means, okay, scientific notation says 6, and then we're going to move this decimal spot 23 spaces to the right. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Alright, I'm going to make that smaller just so that we can actually see what's going on here. Well, these guys better be smaller too then. Okay, so this is the same number. This is 1 mole of something right there. Do you see how huge that number is? That is stupid. We're never going to write it like that. It doesn't make sense. So we're going to write it like this. Okay, 6.02 times 10 to the 23rd. This is just a way of using scientific notation. And whenever we multiply something by 10 to the power, that means we're going to move the decimal point over that many spaces. So that's a huge number. That's all I really want you to see. Alright, so let's kind of go back to where we were. Boom, boom. There we go. Okay, so Avogadro's number. We can work with this. Put this back. Now, the next thing we're going to learn is a little bit of review, but we got this thing called molar mass. Guys, this is that stuff on the periodic table that tells how much a certain element weighs. Now, the reason that we are talking about this one second, even though we've already learned about this, is that the number on your periodic table, the average molar mass, that's for 1 mole of those atoms of that element. So, if you look at, let's say, carbon, okay, if you have your periodic table, get that out, and let's look at carbon. Carbon's molar mass is 12.01. Now, the reason that's important is that means that in 1 mole of carbon, so 6.02 times 10 to the 23rd atoms of carbon, okay, individual atoms, that weighs this 12 atomic mass units. Okay, so molar mass is how many grams 1 mole weighs. 12 grams is not very much. Okay, that's like 12 paper clips. So we're saying that there's 6.02 times 10 to the 23rd atoms of carbon, and if we had a pile of that, that would weigh the same as 12 paper clips. So kind of this whole idea about molar mass. Alright, now that we kind of have this conceptual stuff done, I want to get you and show you how we're going to do these calculations. Guys, this is what we're calling the mole map. Make it real big so you can kind of see it. But what I want you to see is that notice that these are kind of like roads. Okay, this is the exact same thing that we were doing earlier with our conversion factors. If we were going to go from yards to feet to miles, we would have to kind of follow a road. Well, if we want to go from pieces or atoms of an element, we need to get to moles first, and then we can go towards mass. I'm going to let you guys pause this for just a little bit so that you can get this written down in your notes, and then I'll show you how we actually go about using this. Alright, so pause it, get this whole thing written down, and then I'm going to make it smaller so that we can go through it. Alright, now, how this actually works. When we're looking at this kind of stuff, we might want to know how many grams are there in 3.5 moles of copper. Okay, so that's our question. Well, if that's our question, let's see if we can figure out how to answer this thing. Well, if we know that there are 3.5 moles of copper, just like we were doing before, okay, notice that I have my number and I have my unit, just like I did before. Well, if I want to cancel out the unit moles, I'm going to make my fence and rail. Okay, where am I going to have to put this unit if I'm going to cancel it out? Hopefully in your head you're going to say at the bottom. Well, now here is where it's going to get kind of tricky. Guys, I'm going to make this big again. If we're going from, here you go. Okay, let's make those things together, put those off on the side. We'll come back to that. Okay, if we're going from moles to grams, notice that here's where we're at on our kind of road. We're going from moles, we're going to grams. We're going to use this conversion factor that's right in the middle, and that's 1 mole of copper equals blank grams of copper. You're going to notice that I put this little red thing in here that says molar mass from the periodic table. Okay, that's just the number on your periodic table, kind of underneath. On your periodic table, it's right underneath the name. So if we're looking at that, what we know is, better make that smaller. Okay, bring that back down. Okay, I know, I'm going to do it down here. I know that the molar mass of copper is 63.55 grams. Oops. Okay, so what that means is, if I'm looking back at our mole map, okay, I know it's kind of hard to see, that's why I wanted you to write it down earlier, but I know that I'm going to have 1 mole equals 63.55 grams. Well, now that I have, okay, moles on the top and on the bottom, I can cancel them out. And the only unit I'm left with is grams, which, if you look back to our question, how many grams are there in 3.5 moles of copper? We've answered that. Okay, so from here, there we go. Okay, it's just putting it in our calculator, right? 3.5 times 63.55 divided by 1, and our answer in this case is 222 grams. Okay, so you're going to notice it's not any different, it's just now we're using this new conversion factor of molar mass, okay, that now that we know we have from the periodic table, we can get that. Okay, so let's kind of put this over here, and we can even do another example if we want, right? Again, guys, if you need to pause, you can do that for sure. Okay, next one is, this is a slightly different kind of example because we're going to use our other conversion factor from moles to pieces of that. So that would be how many atoms of helium are in, let's say 2.7 moles. Right, so there's kind of our question. That's where we'll start with. Well, just like we did when we were doing it before, okay, we're going to start with our 2.7 moles of helium, and if we set up our Fencing rail and I want moles of helium to cancel out, where does it have to go? Right, if it's on the top here, it needs to go on the bottom there. So we just copy that down. Okay, and moles is down there. Okay, again, I'm going to kind of get this guy out of the way. We'll just put him over there so that we can see this thing again. Here, we're going from moles to pieces, so we're using a different conversion factor. 1 mole equals 6.02 times 10 to the 23rd pieces. Well, so what we put is 1 mole equals 6.02 times 10 to the 23rd. And atoms and pieces are kind of the same thing. Doesn't really change it at all. And from there, right, it's just we're going to use our calculator and figure kind of this out. When you put this number into the calculator, guys, just put it in parentheses. 6.02 times 10 to the caret 23, and that makes it pretty simple. Okay. And that equals 1.6 times 10 to the 24th. Alright, so guys, all we're doing is we're just using different conversion factors the same way that we have before to figure out, you know, what we're talking about with atoms. Okay, nothing's changed at all. So, kind of here's our two examples. I'll make them bigger so you can see them. But this is what we're going to practice, and we're going to get really good at this.